+1 678 648 4277. Support at statisticsassignmenthelp.com or https://www.statisticsassignmenthelp.com. Problem 1. Professor Plum, Mr. Green, and Miss Scarlet are all plotting to shoot Colonel Mustard. If one of these three has both an opportunity and the revolver, then that person shoots Colonel Mustard. Otherwise, Colonel Mustard escapes. Exactly one of the three has an opportunity with the following probabilities. PR for Plum has opportunity equals 1/6 PR, Green has opportunity equals 2/6 PR, Scarlet has opportunity equals 3/6. Exactly one has the revolver with the following probabilities, regardless of who has an opportunity. A. Draw a tree diagram for this problem. Indicate edge and outcome probabilities. PR, Plum has revolver equals 4/8 PR, Green has revolver equals 3/8 PR, Scarlet has revolver equals 1/8. statisticsexamhelp.com. P PGG GS April 8th March 8th March 8th April 8th January 8th January 6th February 6th. Solution. A. 4/48 3/48 1/48 8/48 6/48. SS PGS April 8th March 8th March 8th January 8th January 8th February 6th March 6th. Opportunity revolver prob. 2/48 12/48 9/48 3/48 statisticsassignmenthelp.com. B. What is the probability that Colonel Mustard is shot? Solution. Denote each outcome with a pair indicating who has the opportunity and who has the revolver. In this notation, the event that Colonel Mustard is shot consists of all outcomes where a single person has both P, G, G, SS. The probability of this event is the sum of the outcome probabilities, PR, PP, G, SS equals PR, PP, plus PR, GEG, plus PR, SS equals 4/48 plus 6/48 plus 3/48 equals 13/48. C. What is the probability that Colonel Mustard is shot, given that Miss Scarlet does not have the revolver? Solution. Let S be the event that Colonel Mustard is shot, and let North by East the event that Miss Scarlet does not have the revolver. The solution is statisticsassignmenthelp.com. D. What is the probability that Mr. Green had an opportunity, given that Colonel Mustard was shot? Solution. Let be the event that Mr. Green has an opportunity, and again let S be the event that Colonel Mustard is shot. Then the solution is Problem 2. There are 3 prisoners in a maximum security prison for fictional villains: the evil wizard Voldemort, the Dark Lord Sauron, and Little Bunny Foo-Foo. The parole board has declared that it will release 2 of the 3, chosen uniformly at random, but has not yet released their names. Naturally, Sauron figures that he will be released to his home in Mordor, where the shadows lie, with probability 2/3. A guard offers to tell Sauron the name of one of the other prisoners who will be released, either Voldemort or Foo-Foo. However, Sauron declines this offer. He reasons that if the guard says, for example, Little Bunny Foo-Foo will be released, then his own statisticsassignmenthelp.com probability of release will drop to 1/2. This is because he will then know that either he or Voldemort will also be released, and these 2 events are equally likely. Using a tree diagram and the 4-step method, either prove that the Dark Lord Sauron has reasoned correctly or prove that he is wrong. Assume that if the guard has a choice of naming either Voldemort or Foo-Foo, because both are to be released, then he names one of the two uniformly at random. Solution. Sauron has reasoned incorrectly. In order to understand his error, let's begin by working out the sample space, noting events of interest, and computing outcome probabilities. StatisticsAssignmentHelp.com. Define the events S, F, and F as follows. F equals guard says Fufu is released. F equals Fufu is released. S equals Sauron is released. The outcomes in each of these events are noted in the tree diagram. Sauron's error is in failing to realize that the event F, Fufu will be released, is different from the event F, the guard says Fufu will be released. In particular, the probability that Sauron is released, given that Fufu is released, is indeed 1/2. But the probability that Sauron is released given that the guard merely says so is still 2/3. StatisticsAssignmentHelp.com. So Sauron's probability of release is actually unchanged by the guard's statement. Problem 3. You shuffle a deck of cards and deal your friend a 5-card hand. A. Suppose your friend says, I have the ace of spades. What is the probability that she has another ace? Solution. The sample space for this experiment is the set of all 5-card hands. All outcomes 52 are equally likely, so the probability of each outcome is 1/. Let S be the event that 5 your friend has the ace of spades, and let A the event that your friend has another ace. Our objective is to compute. StatisticsAssignmentHelp.com. The number of hands containing the ace of spades is equal to the number of ways to select 4 of the remaining 51 cards. Therefore, the number of hands containing the ace of spades and at least one more ace is, here the first term counts the number of hands with one additional ace. Since there are 48 ways to choose the extra ace and ways to choose the other cards. Similarly, the 2nd term counts hands with 2 additional aces, and the last term counts hands with all 3 remaining aces. In probability terms, we have. Substituting these results into our original equation gives the solution. StatisticsAssignmentHelp.com. B. Suppose your friend says, I have an ace. What is the probability that she has an 4 1 4 2 4 3 4 4 4 3 2 1 other ace? Solution. The sample space and outcome probabilities are the same as before. Let be the event that your friend has at least one ace, and M be the event that your friend has more than one ace. Our goal is to compute. The second equality holds because your friend surely at least one ace if she has more than one, that is, ML. The probability that your friend has at least one ace is. The first term counts hands with a single ace, since there are ways to choose the ace 48 and ways to choose the remaining 4 cards. The remaining terms are similar. The 4 probability that your friend has more than one ace is. StatisticsAssignmentHelp.com. Plugging these results into the original equation gives. C. Are your answers to A and B the same? Explain why. Solution. The answers are different. There are 4 aces, so there are 16 different subsets of aces that your friend could have. If your friend says, I have the ace of spades, then 8 of these subsets are ruled out, those not containing the ace of spades. However, if your friend says, I have an ace, then only one subset is ruled out, the subset containing no aces. Thus, the probability that your friend has a second ace is different in these 2 cases, because we are conditioning on 2 very different events. Problem 4. Final phobia is a rare disease in which the victim has the delusion that he or she is being subjected to an intense mathematical examination. A person selected uniformly at random has final phobia with probability 1 out of 100. StatisticsAssignmentHelp.com.